All right, sixth grade. We are talking about slope today. When you ride a bike up or down a hill, the steepness of the hill affects the speed that you travel. Most of you probably prefer riding your bike down the hill, right, Hallie Joy? Than up the hill. The slant or the grade of the hill is determined by the change in the vertical rise compared to the horizontal run. For example, if a hill rises 5 feet for every 1 feet of horizontal distance, remember that. So when we're talking about vertical rise, we're talking about going up. This would be the vertical rise. And how much does it go up over how far it moves horizontally, which is the run, okay? So the slant or grade of the hill is determined by the change in the vertical rise compared to the horizontal run. For example, if a hill rises 5 feet for every 100 feet of horizontal distance, the grade of the hill is 5 per 100, or a 5% grade. Similarly, the steepness of a line is the ratio, because this is a ratio right here, is the ratio of vertical change over horizontal change. This ratio is called the slope of a line. A very steep line has a larger slope than a gradual ascent. Very steep line, not so steep of a line. That would be more gradual, okay? Which one would you rather ride your bike up? Probably the more gradual one, okay? So the rise is the vertical change from point P1 to point P2 on a line. That is the rise right here. How far does it change vertically? Okay. The run is the horizontal change from point P1 to P2 on a line. So how far does it change horizontally? Okay. And the slope of a line is the ratio of rise over run. So slope is equal to rise over run. Okay? The rise from point P1 to P2 is 2 because it goes up 2 units. Okay? So the rise is 2, and the run, how many units does it go horizontally? 1, 2, 3. The run is 3 units. Therefore, the slope of the line shown here is 2 over 3, okay? So the slope of this line right here is 2 over 3. That's the slope. If the slope is an improper fraction, do not change it to a mixed number. No mixed numbers for slopes. If you change your slopes to mixed numbers, even if they're right, I'm marking them wrong. Slopes stay as improper fractions, okay? So slope, again, is rise over run, which is the change in y, because that is our vertical, over the change in x, because that's horizontal, because this is our x-axis moving horizontally, okay? Here's our x, and our y-axis moves vertically, okay? So slope is equal to rise over run, which is the change in the y over the change in the x. Example number 1 says find the slope of the line shown. So first we're going to look at our rise. What is the change vertically? So what we want to do is we want to figure out how many units do we go up from P1 to P2. So we're going to drop a vertical line down here till we get to P1, and we're going to see how many units that line is. 1, 2, 3, 4, 5, 6. Okay, so the rise of this line, it's a change of 6 units, okay, over the run, because slope is equal to rise over run, the change in y over the change in x. So now do a horizontal line and we go 1, 2, 3, 4, 5 units of a horizontal change. So the slope of this line, the rise over the run, is 6 over 5. That is the slope of this line. Okay, skill check number 1, find the slope of the line shown. We're going to first figure out the rise because we always look at the change in the y first. Change in y. Okay, so 1, 2 units. 2 units up. Okay, so our rise is 2 and slope is equal to rise over run. Run, change in x, 1, 2, 3 units, okay? So the slope of this line is 2 over 3, the change in y over the change in x. The slope of a line can be positive or negative. If the line slants up from left to right, it has a positive slope. If it slants down from left to right, it has a negative slope. When determining slope, if you move down for the rise or left for the run, use a negative integer to represent the distance. So example number 2 says find the slope of the line shown. Now, remember what we just said over here. If your line slants down from left to right, it is a negative slope. Notice that this line is slanting down as we move from left to right. So the slope of this line, let me just make sure we can see those points. The slope of this line is going to be a negative slope, okay? Because this line is moving down as we move from left to right. It's slanting down. So this is going to be a negative slope, all right? Now, what is our change in y? Notice that P1 is higher than P2. So our vertical change is a negative change because we're moving down. And how many units is that negative change? 1, 2, 3, 4 units. Okay, 4 units because now we're even with P2. So the rise is a change of 4 units, but it's a negative 4 because it's moving down. Okay, the run is positive. Okay, because we're still moving from left to right. 1, 2, 3, 4, 5, 6 units. So negative 4 over 6. Now, I said don't change a mixed number to an improper fraction, but you do want to reduce your fractions if possible. Okay, so we have, oh, and I'm sorry, I should have written run. I'm going to keep emphasizing that over and over and over again because that's the key to the slope. So the slope of this line is negative 4 over 6, which reduces to negative 2 thirds. So the slope of this line is negative 2 thirds, all right? Now, the fraction negative 2 thirds is the same as negative 2 over 3 or 2 over negative 3. When the slope is negative, you can think of either the rise or the run as being negative. One of them is going to be negative, the other is going to be positive, okay? Skill check number 2, find the slope of the line shown, okay? This is another line that is a negative slope because as we move from left to right, it slants downward, okay? Let's figure out our rise over run, that slope, okay? The rise is the change in y, 1, 2, 3, 4, 5, 6 units. 1, 2, 3, 4, 5 units horizontally. 6 over 5, it's a negative slope. So it's negative 6 over 5. A horizontal line has a slope of 0. Here is a horizontal line. There is no slope. It is perfectly straight. Okay? P1 and P2, right here and right here, are on the same horizontal line. Therefore, the rise is 0. It's not moving up or down. The rise is 0. You cannot move up or down from P1 to P2. The run is 4. the slope, rise over run, is 0 over 4, which is equal to 0. So the slope of a horizontal line is always 0. The slope of any horizontal line is always 0. A vertical line has no slope. Okay, no slope. P1 and P2 are on the exact same vertical line. The rise is 4, but the run is 0. You don't move right or left as you move from P1 to P2. So when we write rise over run, we get 4 over 0. Division by 0 is undefined, so no slope exists. We cannot divide by 0. No matter which 2 points are chosen on a vertical line, the run is 0. No vertical line has a slope. Okay? So, key here, horizontal line, always slope equal to 0. Vertical line, always no slope. Okay? You do not need to graph a line to find its slope. You can use the slope formula to calculate the slope if you know any 2 points on the line. Either point can be labeled P1 and the other point is labeled P2. So we're going to learn a formula. Okay? The slope of a line containing points P1, x1, y1, and P2, x2, y2 is m. Okay? And here is the formula. M is equal to rise over run, that's slope, okay, which is equal to the vertical change, or the change in y, over the horizontal change, the change in x, which is equal to y2 minus y1 over x2 minus x1. Now, you cannot do y2 minus y1 over x1 minus x2. Big fat no through that, okay? y2 minus y1, x2 minus x1. So let's look at an example of this. Example number 3. Find the slope of the line through 1, 6 and 3, 4. So we are going to call point 1, 1, 6. And we're going to call point 2, 3, 4. So this is x1, and this is y1, and this is x2, and this is, whoops, y2. So now I'm going to plug what I have into my formula. M is equal to y2 minus y1 over x2 minus x1. So y2 is 4, y1 is 6, so 4 minus 6 over x2 is 3 minus x1 is 1. 4 minus 6 is negative 2. 3 minus 1 is 2. Reduce that because it gives us a whole number, okay? And our slope is negative 1. That is not a mixed number. It is a whole number, and it is negative 1. So a slope of this line is negative 1. Example number 4. Find the slope of the line through negative 2, 4, and 3, negative 3. We're going to say P1 is negative 2, 4, and P2 is 3, negative 3. Slope formula. M is equal to rise over run, which by our formula is y2 minus y1 over x2 minus x1. Okay? And if this is P2, we have x2, y2, sorry about that, and we have x1, y1 over here, so plug in what we have. y2, negative 3, minus y1, 4, over x2, 3, minus x1, negative 2. Negative 3 minus 4 is negative 7. 3 minus negative 2, That's the same as 3 plus 2. That is 5. Do not change this improper fraction into a mixed number. The slope of this line is negative 7 over 5. Skill check number 3. Find the slope of these lines. Okay, so we're going to call this one P1 and this P2. So this is x1, y1, x2, y2. M is equal to y2 minus y1 over x2 minus x1. Plug in what we know. Y2 is 2. Y1 is 6. So 2 minus 6 over x2 is 1. X1 is negative 1. 2 minus 6 is negative 4. 1 minus negative 1, that is the same as 1 plus 1, that is 2. Okay, so that slope reduces to negative 2. Over here, first point is P1, second point is P2. M is equal to y2 minus y1 over x2 minus x1. So here we have x1, y1, x2, y2. So y2 is 1. Y1 is 3. 1 minus 3 over x2 is negative 1 minus x1 is 6. 1 minus 3 is negative 2. 1 minus 6 is negative 7. We have a negative over a negative, which means that is positive, because negative divided by negative is positive. So the slope of this line is 2 over 7. And that is how you calculate slope.